My last video on solving more basic trig equations, and we're going to look at a situation in which you need to factor, but factoring doesn't work, and so what we're going to have to fall back on is using the quadratic formula. So this is kind of review in this video, and kind of not. So we say solve for the angle theta that's going to make this equation true. And by the way, I want my angle in degrees, and I want it only between 0 and 360, so we don't have to give all possible angles that make this true, but just the ones between 0 and 360. So the first thing is this: when somebody asks me to solve a trig equation, I'm really naturally inclined to try to get the trig function by itself. It's just that when you have a sign to the second power and you have a sign to the first power, it's really not a thing that you can do and have any success at doing, or at least it's not going to give you any insight into the angle. So I do also notice this though: if I had a sine squared and a sine to the first and a constant term, then what this does is it looks like something that is in quadratic form. Okay, we call this quadratic form. Quadratic form, or at least that is a standard form of an equation that is quadratic. So what we're going to try to do is we're going to factor this, and we're going to try to get it to say something like something times something equals 0, a times b equals 0. And if that's the case, then one of them had to be equal to 0. We can set them each individually equal to 0 and solve. So in this instance, we're going to see that factoring fails, and then ask ourselves what to do after that. Okay, so taking a look at this, the first thing we're going to do when we factor is make sure that one of the sides is set equal to 0. And so since we already have this, what I'm going to do is I'm going to try to go ahead and factor this using kind of like a reverse FOIL method. But essentially I want to start by getting my first two terms to produce this first term right here. So we say, what can I multiply to get 2 sine squared of theta? I would have to have a 2 sine of theta, and I'd have to have a sine, 1 sine of theta. So those are going to give me my 2 sine theta. I say, well, give me two numbers that multiply out to be, say, a negative 1. Well, now there are not many to choose from here. I could say like a positive 1 and a negative 1. And that would give me the negative 1 in the back here. Now we need to check to see that we get this middle term. So we've done the first, we've done the last, we need to check the O and the I. So if I check my outer and inner multiplications here, you'll see that I get, I'll do this off on the side here, we would get 2 sine of theta, actually a negative 2 sine theta, and I would get in the middle here, the inner two terms, a positive 1 sine of theta, and so those add up to be a negative 1 sine of theta, which is not what we have as a middle term here. So maybe, just maybe, we could go back and we could change this to a negative and change this to a positive, but you'll notice here that all that does is switch these signs over, and then you get a positive sine of x. And so factoring essentially fails here. So what we're going to do is we're going to use the quadratic formula. So we say, what is the quadratic formula in the first place? Recall, it basically says this: if you have something in quadratic form looks like this, and it's equal to 0, then the x values that we're looking for in the first place equal this, negative b plus or minus the square root of something all over 2a. So negative b over 2a, that's kind of the standard thing. And we say this in here is b squared minus 4 times a times c. So the first thing we're going to need to do here is we're going to need to recognize that this is in quadratic form, and that we could recognize what the values of a, b, and c are. So looking up here at this trinomial, we have 2 sine squared of theta plus 2 sine of theta minus 1 equals 0. We say, looking at this, we have an a value of 2, a b value of 2, and a c value of negative 1. So I would say, okay, what I'm going to get here is x equals all of this stuff here. Now you'll notice that when I say something of this form, x equals these values right here. But when we're talking about something that's trigonometric, I'm saying I don't have x's, I have sines of theta. So when we do this, we're going to write it this way. We say, well, then the sine of theta comes out to be negative b plus or minus the square root of b squared minus 4ac all over 2a. And so all we need to do now is basically be familiar with our quadratic formula and recognize that this is what our sine of theta equals, which is great because we can undo sine after we're done with this. So we say, what are our values here? Well, our b values, we say negative b, so 2, and another b goes here, so b squared minus 4ac. These are both a here and here, so we say a is 2, and we say c is negative 1. So let's go ahead and simplify this. We get sine of theta is equal to negative 2. All over 2 times 2 is 4. And then we say plus or minus what square root here. So we get 4. And then we have a negative 4 times a positive 2 times a negative 1. Well, 4 times 2 times 1 is 8. And a negative times a negative is a positive. So I get this right here. So we say sine of theta is equal to negative 2 plus or minus the square root of 12 all over 4. Okay, so what we're going to do is basically clean this up a little bit, and I'll get my calculator to do it, but I want a couple of decimals. So the first thing I want to do is this. I want to find what is negative 2. Let's write this differently. We say sine of theta equals negative 2 plus the square root of 12 over 4. and the sine of theta equals -2 minus the square root of 12 over 4. We want to get decimals for both of these because we're dealing with some, extensive numbers. So let me get my calculator out over here. We say, all right, first thing I'm going to do is I'm going to find the square root of 12. My calculator is a little bit different, so it's not scientific. I have to type them in a different order. But we say square root of 12 is this. We say plus a -2, okay, would give me this here, and we'll divide that by 4. So I get approximately, we'll go 4 decimal places here, about 0.3660. So we say sine of theta is approximately 0.3660. We're going to keep this in our back pockets. We're going to go find this one over here now. So now, instead, we'll do the square root of 12 again. So we say square root of 12, which is what we had. And it's negative. We have minus the square root of 12. We're going to add this to a -2. So my quick way of doing that is taking 2 more away. But we get this here, and we divide this by 4. And we get negative 1.3660. So we say sine of theta equals negative 1.3660. So here's what we need to do now. We're going to do sine inverse of both sides of this. Kind of a simple thing to do. We say theta equals sine inverse of 0.3660, and theta equals sine inverse of negative 1.3660. The first one I want to point out is this one right here. We say theta doesn't exist. And the reason why, again, as we said, the biggest sine or cosine can ever get is -1, or +1 is at the largest it could ever be. -1 is the smallest it could ever be. This has gone below -1, so this isn't going to work for this one. This one, though, does actually work. So let me get my calculator out here. We're just going to approximate. We say 0.3660. We're going to do the sine inverse of this. So sine inverse, and in degrees it gives us a 21. We're going to go to the nearest 10th. So we say theta hat is approximately 21.5 degrees. So one thing I want to comment on here is this. The calculator did not tell me the actual angles I'm looking for. Well, you know what it told me? It told me the reference angle. Okay. So what we need to do now is we need to sketch this situation out. We say, all right, give me all the angles that have a 21.5 degree reference angle. I'm going to label one of these. This is 21.5 degrees, and all of these are congruent reference angles here, congruent. But we say, all right, here's what I recognize from this. I'm doing sine, and sine came out to be a positive 0.3660. So if sine is positive, it means I was either in the first quadrant or I was in the second quadrant. So these two angles that we got here, the actual angles between 0 and 360, we say are approximately 21.5 degrees because that was this angle here. And the other angle is here, 21.5 degrees short of 180. So getting my calculator out, we say, all right, if I were to take 180 and subtract off 21.5, I would get roughly 158.5. So my other angle here is 158.5. And this is a very good example of using the quadratic formula to solve these things out. Cheers.